Hello everyone, today we are going to discuss with you our next topic, that is organic compound containing nitrogen. Now, firstly, I am going to show you the preparation of amines. Before that, to know the preparation of amines, I want to tell you some of the what is exactly amine means. Okay, amine is suppose this one RNH2. This is amine. Okay, NH3 ammonia. This one is ammonia, and the derivative means one hydrogen. Remove one hydrogen and put this R group over here. R can be anything, that is methyl, ethyl, or propyl. So this is amine. Okay, so what is, suppose I will show you. I have this one RNH2. Degree of this amine is primary amine. Primary amine. Why this is primary amine? You need to make this primary amine because this nitrogen connects with only one R group. Okay. Another one is RRH. Okay. This one is secondary amine. Secondary amine. Because this nitrogen connects with two other R groups. Can be methyl, can be ethyl. Okay. Another one R the degree of this is tertiary amine. Tertiary amine. So this is 3-degree amine. This is 3-degree amine. Other than R group, here we have a lone pair too. We have a lone pair. All the amines have tetrahedral structure. Tetrahedral structure. So the tetrahedral structure should have angle 109 degree, 28 this one. But here the angle is 180 degree. In the case of amines, it is 180 degree. This is because of the repulsion caused by these lone pair and the bone pair. The repulsion caused by these lone pair electrons, and this bone pair is going to somewhat shift or somewhat compact. Okay, that's why this is the angle is 180. Okay, now this is the classification. This is ammonia, after that the primary amine, after that the secondary amine, and then the tertiary amine. The derivatives of ammonia, this is amine is derivative of ammonia obtained by the replacement of 1, 2 or all the 3 hydrogen atom by the alkyl or the aryl group. It can be alkyl group or it can be aryl group too. This is our alkyl group. Alkyl is like CH3, CH3, CH2, CH3, CH2, CH2. This bond is attached to the nitrogen atom. Okay, so these are the alkyl groups. Okay, now the next one is aryl groups. Aryl group can be benzene, and here if it is attached to N, this nitrogen still, it's a primary amine. Primary amine. Okay. Now the nomenclature of this ammonia. Nomenclature, common name. Aliphatic amine is named by prefixing alkyl group to the amine. In secondary and tertiary amine, the prefix di or the tri is put before the name of alkyl group. IUPAC name, replacement of E of the alkenes by the word amine. Suffix E of the arene is replaced by word amine. Suppose I will show you. I have this one, CH3NH2. This is a primary amine. So this is methyl amine. Methyl amine. This is methylamine. CH3CH2NH2. This one is ethylamine. This is for the primary amines. Okay, or you can say N-methyl amine. N-methylamine or N-ethylamine. Okay, you can see here the aliphatic is named by prefixing alkyl to the amine, and in the secondary it's ditri. The replacement of E of the alkene by the word amine. So you can use this nomenclature. Now the next one is the preparation of amines. The preparation of amine. First preparation of amine is reduction of nitro compound. Now this one is nitro compound. Nitro is NO2, and in the presence of hydrogen and palladium. Palladium is a catalyst over here and ethanol is a solvent. Hydrogen and palladium, you will get a compound that is amine. This compound is aniline, and this is very important. Aniline is very important, and the plus NO2. Now after that, HCl or FeHCl, it will further reduce this NO2 to the NH2, and this is a very important compound. This is the reduction of nitro compound. I am putting this nitro group like this, NO2. After that, hydrogen palladium you can use, and ethanol. Reduction means the removal of oxygen or the addition of hydrogen. So removal of this, another nitro compound I am taking, and in the presence of iron HCl and tin HCl, you will get this NH2. Okay. Now the next one is ammonolysis of alkyl halides. Ammonolysis of alkyl halides means this alkyl halide is going to get the ammoniated products. Okay. Ammonolysis of alkyl halide, I'll show you. Ammonolysis of alkyl halides. I have alkyl halide. Halogen is more electronegative, so it is delta negative. It will be delta positive. Ammonia is here. Nitrogen has lone pair negative charge over it, and it will attack on this one. RNH3 positive. So this is ammonolysis, because nitrogen is donating its electron, so you can put it like this. This is a salt, ammonolysis salt. Okay. Always remember, a nucleophile is going to attack over the electrophile. Okay. So you can see here, this is the compound that is formed. Now after that, reduction of nitriles. Reduction means the addition of hydrogen by the removal of these triple bonds. This triple bond is going to convert into the single bond, and hydrogen got attached to it. Now, what is this? The reduction of nitriles. R, C, triple bond, and these are nitriles. In the presence of hydrogen palladium or Na amalgam, sodium amalgam, ethanol, both of these are reducing agent. You can use any one of these. Nitrile, this double bond going to get break, hydrogen over here, another double bond going to break, hydrogen, CH2 and H2. This is amines. Preparation of amines from the nitriles. Okay. Now this we have covered. Then the amides. Amides are going to get reduced by lithium aluminium hydride. RCO and H2. This is amide. By using lithium aluminium hydride, this amide is going to convert into amines. this amide is going to convert into amines. Okay, RCONH2. And after that, the Gabriel thalamide synthesis, and this is a very important reaction, Gabriel thalamide synthesis. So in the starting, we need to choose this thalamide. How we can prepare this thalamide? First, you need to take phthalic acid. Phthalic acid, this one. Removal of water molecules. You will get an anhydride. After that, formation of, with the reaction of ammonia, you will get thalamide. Okay. Now, after that, the thalamide is going to react with the KOH. KOH, you know, OH negative is a base. It will abstract a proton from here. Okay, or H2 is going to get removed, and minus and K positive. We have this one, CO, NH, CO, KOH. Nitrogen is an electronegative atom. So it wants to have a negative charge over here, and it will be a positive charge. So OH negative is going to attack on this. It will be CO and minus K positive. After that, RX reaction on this one. This negative is going to attack on this delta positive. You will have CO, and R. Okay. After that, the hydrolysis. Hydrolysis of both OH and H and OH. You will get a phthalic acid again from the thalamide. And RNH2. This is our prepared ammonia. Okay, amines, prepared amines. Sorry. Okay, so this is about the next one. Here we use aqueous NaOH, the basic hydrolysis. After that, the Hofmann bromamide degradation. This is also a very important reaction from exam point of view. Hofmann bromamide degradation. We have this one, RCONH2. You need to remember that in presence of KOH and Br2 means alkaline, okay, alkaline nature, and the Br2 it should be there. You will get RNH2, KBr, Na2CO3. This will be the products, okay. KBr or NaBr you can say. Now remember that 4 moles of NaOH is there. Now what is the difference? Here also we are taking RCONH2, here also we are taking RCNH2, but remember that here we are getting amine with 1 carbon less than the parent amine, but here we are getting amine with the same number of carbon as that of the parent amine. That's why this is degradation reaction, means 1 carbon is less than the parent compound. Okay, so that's why these are the preparation of amines. You can see the reduction of a nitro compound, the removal of oxygen and the addition of hydrogen. The reduction takes place. After that, the reduction of the nitriles, the addition of hydrogen takes place. After that, the amides reduction, it reduces to CH2 and NH2. Gabriel thalamide synthesis, you will get a final product of amines. After that, Hofmann bromamide degradation, you will get a RNH2 product, amines product. Okay. Now the next one is physical properties. Physical properties that we can see easily, that we can see the temperature, we can boil it for seeing the physical property. For example, lower aliphatic amines are gases. Means why they are gases? They are gases because of the weak bond forces of attractions between the molecules. And then the primary amines with 3 or more carbon atom are liquid and higher ones are solid. More the interaction, more it will change from gases to liquid, liquid to solid. After that, aryl amines are colorless but get color on the storage. Aryl amine like aniline will get aniline is colorless, but it will be somewhat brownish like color on storing it. Okay, so you need to again boil it to get a clear solution, because they will get impurities, and because of which they will get a color. After that, lower aliphatic amines are soluble in water, while higher are insoluble in nature. Lower aliphatic amines are soluble because of the less hydrophobic chain. This is a hydrophobic chain. This is hydrophobic in nature, but if the alkyl chain is going to increase, then more the hydrophobic chain will be there, and that's why it is not going to get solubilized in the water. Primary and secondary amines form intermolecular association. Primary amines form intermolecular association, and then after that, the boiling point. Primary amine have more boiling point than the secondary amine, than the tertiary amine. Why they have more boiling point? Because of the hydrogen bonding. Hydrogen bonding in the case of primary amine is more, because all the nitrogens are free to attract with the other hydrogen atom, other amines hydrogen atom. So because of the strong interaction between these molecules, the boiling point of primary amine is greater than secondary, and which is greater than the tertiary one. Okay, these are the physical properties that are very important. After that, now the next one is the two important one, the alkyl isocyanates and the alkyl cyanides. Okay, now first you can see from here alkyl isocyanates. Alkyl isocyanates, how you can prepare it, I'll show you. Ri means the alkyl halide. You need to take alkyl halide, and on it AgCN is going to attack. You will get RNC plus AgI. Physical property, these are colorless, extremely poisonous, and unpleasant smell liquid, insoluble in water, because these are alkyl isocyanates. After that, the chemical properties of these one are the firstly acidic hydrolysis. Acidic hydrolysis will give you the amines. After that, sodium and ethanol, you will get RNHCH3 HGO, you will get R and C double bond O. Isocyanide, from this you will get these isocyanates. After that, RCN, alkyl nitriles. Okay, alkyl nitriles, CN, Ri plus KCN, heating this one, RCN plus Ki. The physical property is neutral with unpleasant smell, moderately soluble in water, and RCN on alkaline hydrolysis will give you RCOH plus NH3. Again, Ra in the presence of sodium and ethanol, RCH2NH2. I'll show you this again. Okay, so firstly, this we have done. After that, physical properties of amines, we have clear that the boiling point of primary amines are greater than secondary, greater than tertiary, because of the hydrogen bonding in primary amines, in 1 degree amines, more hydrogen bonding, and the secondary amine and tertiary amines mostly do not get the hydrogen bonding, do not have the hydrogen bonding. That's why interaction, and due to interaction, the boiling point of primary amine is more than that of the secondary amines. After that, basic character of amines. Okay. Remember, basic character of amines in the gaseous state. In gaseous state, if there is no solvent, the amines have the basic character like this: R2N, R2NH, RNH2, because of the electron releasing factor due to inductive effect. More the electron releasing it is, more the negative charge over this nitrogen, then it will act as a more basic than the other ones, other secondary and primary amines. Okay, in the aqueous solution, you need to remember the order of the primary and secondary amines. In aqueous solution, 2 degree, 1 degree, 3 degree. If alkyl is equal to methyl, if alkyl group is equal to methyl group, 2 degree, 3 degree, 1 degree, if alkyl group is not equal to methyl group. You need to just remember that this is the combined effect of three factors, that is inductive effect, hydrogen bonding, and solvation. Combined effect, hydrogen bonding, solvation, and the next one is steric hindrance. This is the combined effect of these four factors. Okay, so remember that if R is equal to methyl, you need to take 1 degree, 2 degree. Sorry, if R is not equal to methyl, then 1 degree, 2 degree, 3 degree, because here the 1 degree alkyl halide is least sterically hindered. That's why it is going to attack more as a basic one. If R is equal to methyl, then you can take 3 degree also. Okay, so this is the order. Wait a minute. So if R is equal to methyl, then this is the correct order. Okay, R is equal to methyl, then this is the correct order, because methyl is going to be shifted by this one, 1 degree. If R is not equal to methyl, then 2 degree, 3 degree, 1 degree, because if 3 degree is there, only 2 hydrogen is compensating, so you can take this one. But for the, if R is equal to methyl, then it's difficult to have 3 hydrogens in near nitrogen. That's why this is the order. You need to remember the aqueous solution. Okay, in the aqueous solution. So this we have done. Now the next one is reacts with base to regenerate parent amine. It can react again with base. How I will show you. Suppose I am having this one, R and H3 positive, X negative. OH negative is going to take up this hydrogen, RNH2 plus H2O plus X negative. So this will be the reaction, and you are getting the parent amine again. The order of stability of ions is like 1 degree, 2 degree, and 3 degree. Okay. Now the next one is, before moving forward, I'm going to show you the preparation of a cyanide and a isocyanide. So the preparation of cyanide and isocyanide, it's a very important question, and here one twist is there. You need to remember this Cn. Cn negative means on the carbon negative charge is there, on nitrogen we have lone pair. So this is an ambident nucleophile. Ambident nucleophile. Ambident nucleophile, what does that mean? Ambident nucleophile means the nucleophile which can attack through two sites. Two sites. Okay. So I have Ri and I am using KCN, and Ri I am using AgCN. Okay. So in this case you are going to get RCN. In this case you are going to get RNC. So you have a question in your mind that in both the reagents you have CnCN, but why you are getting alkyl nitriles here and alkyl isocyanides here? So there is a twist that how you can do this. If it is a KCN, this is an ionic bond. There is an ionic bond between potassium and carbon. So here because of the electrostatic force of attraction, you are going to separate this K and C completely. K positive and Cn negative. If I have this AgCN, now there is a covalent bond between Ag and C. Covalent bond between Ag and C. Now it is not going to break like this. Nitrogen has a lone pair over here. Then it can here from the nitrogen will act as a nucleophile here. Nucleophile here is nitrogen. Here the nucleophile is carbon. Nucleophile is carbon. Okay. So here carbon is going to attack. Now how? RICN negative. R will have delta positive, I will have delta negative. C negative is going to attack on this, but carbon cannot have more than 4 bonds, so it needs to get dissociated. RCN and I negative. Okay. Or I negative will attach to with the K positive, you will get Ki. Okay. Next one is Ri plus AgCN, and your nitrogen have a lone pair. It can attack on delta positive. Delta positive. I is going to get removed. R N C plus Ag I, because Ag is going to get removed with the I. Okay. So this is isocyanide. This one is cyanide. These are the preparation of cyanide and the isocyanide. Here the twist is that we are using ambident nucleophile. Ambident nucleophile means which can attack from both sides. Okay, that's why this is the preparation of RNC and the RCN. Now again I'll tell you the chemical properties. The nitriles means isocyanides is going to get removed. RCOO means HCOOH and RNH2. ethanol gives RNHCH3 means the reduction. Again HGO, RNCO. Okay. Here the properties, the unpleasant smell and the moderately soluble in water, again because of the hydrophobic nature. Hydrophobic like dissolve like, hydrophobic will dissolve in hydrophobic, and hydrophilic will dissolve in hydrophilic. RCN, H2O and NaOH, you will get RCOH and plus RNH plus NH3, and again the RCH2, the reduction of this compound I am going to show you this with the help of mechanism. This is a very important mechanism and you need to know this. Okay, I have this one, R C triple bond N, again R dash MgX. So this one is our Grignard reagent. Grignard reagent. Remember that carbon is more electronegative than magnesium. This is non-metal. This one is a metal. So delta positive and delta negative over here. You will get a delta positive because carbon is electrophilic in nature, nitrogen is nucleophilic in nature. So this delta negative will attack on this one and this is going to get break. R C R double bond N negative MgX. Okay. Now just you need to remember this one. How you can hydrolyze? You can hydrolyze this by OH2. H2O. H2 will be over here. So RCO R. You will get RNH3 after the removal. Okay, RNH3 will be the product, NH3 will be the byproduct, H2O on the addition of H2O, and the another one is MgOH. Okay, here the H2O is moving here and there. The nitrogen can take up the hydrogen from here, and these two hydrogen you will get RNH3 and you will get NH3, and the OH remaining will attach to this MgOH. Okay, so this is the mechanism for this reaction. Another reaction is like triple bond NaHG ethanol. Again the reduction one, RCH2 and H2. Remove, and you will get the hydrogen over here. Okay, this is done. Now the next one is again all the reactions of first the diazonium salts. Importance of diazonium salts in synthesis of aromatic compound, in preparation of substituted aromatic compound which cannot be prepared by the direct substitution in benzene and substituted benzene. So, okay, I have covered this. Alkyl cyanides I have covered. Now the importance of diazonium salts in synthesis of aromatic compound. You know that benzene, substituted benzene, the formation of substituted benzene is very much difficult. You need to take the different reagents. Okay, suppose Cl2 anhydrous Al Cl3, you need to take up this Cl. Okay, now the next one is diazonium salt. Diazonium salt is like this, N2 positive, Cl negative. So you will have a very much importance of this compound. You can form Cn over here. You can form Cl from this compound. These are the diazonium salts, easily formed. Okay. Now the next, I am going to show you this. I'll show you the Sandmeyer's reaction, Gatman's reaction. By the direct substitution, the substituted aromatic compounds cannot be formed. You can use the diazonium salts for formation of the substituted aromatic compounds. Okay. Now, okay, first I'm going to show this reaction, means the acetylation of amines. Acetylation of amines. C2H5NH, C2H5 plus CH3COC. I just want to give you a glimpse that how this mechanism occurs. Okay, this carbon is delta positive. This carbon will be this oxygen will be delta negative because this carbon is electrophilic and oxygen is nucleophilic in nature. So we have a lone pair over here and it is going to attack on this carbon. you will get CO, C2H5 and C2H5. You will have CO. Now, carbon cannot have 5 bonds, so this bond is going to delocalize over oxygen. And CH3, Cl, hydrogen. Nitrogen will have a positive charge because it is formed a bond by donating the electrons to this carbon. Okay. Now, next one is this one. This oxygen will come back and the Cl, a good living group, will leave. C2H5 and H, C2H5. Okay. Here we'll have positive charge CO, CH3. Now the Cl negative will take up this hydrogen and nitrogen will have the negative. This bond is going to dissociate towards nitrogen and nitrogen will have a negative charge. Negative positive will neutralize itself and the HCl is going to remove. C2H5 and C2H5 CO CH3. So this is the acetylation reaction. This is kind of a acetylation reaction in which acetyl group is reacted with this one. Now the next one is carbyl amine reaction. This is also a very important reaction, carbyl amine reaction. Carbyl amine reaction. Carbyl amine reaction. This is particularly for the detection of primary amines. Primary amines. So if there is a primary amine RNH2, the presence of chloroform and KOH, you will get alkyl isocyanides, and there is a very bad smell because of this alkyl isocyanides and KCl. Okay, next one is the reaction with nitrous acid, and this is also a very important one. Nitrous acid, the reaction with nitrous acid. Nitrous acid is HNO2. How it is formed? NaNO2 and HCl. NaNO2 and HCl, you are going to get HNO2. Now, if I have aniline on reaction with HNO2 or NaNO2 HCl, remember that the temperature here should be very much low, 0 to 5 degrees Celsius. 0 to 5 degrees Celsius or 273 to 278 Kelvin, you will get an aromatic amine N2 positive plus Cl negative. This is a diazonium salt, and if the temperature here will be higher than this one, then this diazonium salt will not get prepared, and you will get, because removal of nitrogen is a driving force for that reaction if the temperature is high in the case of aromatic amines. Okay, so so if RNH2 is there, means the aliphatic amine is there. In the case of NaNO2 HCl, HNO2, you will get R2 positive Cr and N2 positive Cl negative, and in the case of H2O, you will get an alcohol. This is used for the preparation of alcohol, and N2 is going to get removed in HCl. Another is the aromatic amine, that is aniline. In the presence of NaNO2 HCl and the temperature is 273 to 278, you will get C6H5 N2 positive Cl negative, NaCl plus H2O. Now after that, what is the next reaction? This one is the next reaction. I am going to show you. This is SO2 Cl plus this one NH2 C2H5. Now nitrogen lone pair, where it can attack. Remember, nucleophile is going to attack on a electrophile. How it will react? this will be delta positive, this will be delta negative, because chlorine and oxygen both are more electronegative than sulfur. So nitrogen is going to attack on this, but sulfur cannot form more than 6 bonds. So how I'll show this to you: oxygen negative, double bond, Cl on this, and H positive, C2H5. Okay. Now the next one is oxygen negative is going to come back, and this Cl negative is going to remove. After that, this one SO2 NHC2H5 positive. So Cl negative now attack on this one, and SO2 and HC2H5. So this is the final product for this one, benzene sulfonyl chloride. This is benzene sulfonyl chloride. So this is a Hinsberg reagent. Remember the name of this reagent, Hinsberg reagent. Hinsberg reagent. Okay. So this is an important reagent you need to remember. Now the next one is, what is electrophilic substitution? Now remember regarding the electrophilic substitution reaction. Firstly, I want to tell you another thing about this. Is for the primary amines. Hinsberg reagent is used for the detection of 1 degree, 2 degree and 3 degree amines. Now see, I told you regarding this primary amines. Okay. Now this one is soluble in alkali. This is soluble in alkali, means primary amine is soluble in alkali because of the presence of this hydrogen. Now the next one is the secondary amines. Hinsberg reagent is going to react with secondary amine. Secondary amine NHC2H5 C2H5. Okay, again the reaction like this: nucleophile is going to attack on the electrophile. Now the next one is oxygen negative, Cl NH C2H5 C2H5. Here the positive charge because of the formation of 4 bonds. Oxygen again, C2H5 C2H5 H positive. Now Cl negative is going to take up this hydrogen. You will get SO2, nitrogen, C2H5 C2H5 plus HCl. Now this is not going to dissolve in KOH, insoluble in KOH. Tertiary amine do not react at all. 3 degree amine do not react at all. Okay, so that's why you will get the distinction between primary amine, secondary amine and tertiary amine by dissolving it with the alkali, dissolving it in alkali. Okay. Next one is chemical reaction of amines. I am showing you. Okay. After that, the electrophilic substitution reaction. Mainly, electrophilic substitution reaction is shown by the benzene ring. Substitution reaction shown by benzene ring. Benzene ring. Okay. I have this one, benzene ring. Electrophile here is only hydrogen. So I need to substitute this with another electrophile. Suppose I am taking Cl positive. So this is the electrophilic substitution reaction. Now, if I am attaching one group, that is electron releasing group, like nitrogen, NH2. Now, this nitrogen is giving the electrons to the ring. I am showing you the resonating structures of the amines. I have this RNH2 positive, this one, again the resonance over there, this one negative over here, double bond NH2. After that, the resonance over here, negative here, and H2 positive, negative over here, again the resonance, and H2. Okay, so this is ortho, electron density is at ortho, and the para position. So the electrophile is going to attack on this highly reactive, center, because of the negative charge is going to attack on the positive uh, element. Okay, so if I have NH2 on this, Br2H2O, Br2H2O. The electrophile we have is Br positive, and in the case of this, you will get NH2 Br. Okay, so this is tribromide. This is the formula of tribromide. But if we do not want the Br at all the three positions, then how we can control this reaction? We can control this reaction by putting an acetyl group with aniline. I have this NH2, I have this CH3COCl. Okay, this now nitrogen is going to attack on this carbon. Carbon cannot form 5 bonds. That's why you will have NH, here the positive, CO negative, Cl, CH3. Now oxygen cannot is going to backdonate the electron, and Cl is going to leave. Here we have NH, positive, CO, CH3. Again Cl negative will take up this hydrogen. You will have NHCO, CH3 plus HCl. Okay. So now this compound is somewhat less nucleophilic than the other one. Why? Because of this cross conjugation of the electron. Electron can get delocalized on this ring and also on this one. So the negative charge on this ortho and para position is not that much. That's why you will get only one product, that will be the para product, as the major one because of the steric hindrance. And after that acidic hydrolysine, you will get the derivative of aromatic amine, B. Okay, so this is regarding the less nucleophilicity of the of this aniline. This is acid anilide, and it's an important reaction. Acid anilide, because of this acid anilide, because of the cross conjugation, electrons are going to get less delocalized on this ring, and that's why the electrophile is going to attack on this para position. Okay, now the next one is this one. Another one is, this is also very much important, preparation of Diazonium salts we have done. I'll explain it to you again. Next one is amine in the presence of HNO3 and H2SO4. You need to remember the yield of the products. Yield of the para product is 51% and the meta product is 47% and the ortho product is 2%. Why the difference is too much? Okay, that the ortho is only 2% and it should be almost equal to that of the para. Why this is important? Okay, this is acidic condition. This is an acidic condition, and due to which the formation of aniline ion takes place in these acidic condition. That's why the aniline ion, because of the aniline ion, there is no negative charge on ortho position and the para position, and meta is somewhat more. Meta is somewhat more electron dense than the ortho and the para. That's why although you are getting the para product almost 51%, that is due to the NH2, but the meta product is high because of the formation of aniline ion, and aniline ion is going to make a meta product more easily than the ortho one. That's why you are getting the ratio of the products like this, and you need to remember this. 2%, here it is 47%, here it is 51%, and this one is our aniline ion because of the acidic condition that is formed in between. Next one is, in the presence of H2SO4, you will get a Zwitter ion, NH3 positive, SO3 negative. This one is Zwitter ion, which has both the positive and the negative side. This is the Zwitter ion, NH2SO3H. Again, the formation of the diazonium salt, C6H5N2 positive, Cl negative, NaCl and H2O. This is the preparation of a diazonium salt. Physical properties of the diazonium salts is this one, colorless crystalline solid. This is a salt, that's why this is colorless, and it's a crystal type solid, and which is soluble in water, stable in cold. Remember that stability is very much important, but if the water is there, then it will react with water when we are going to heat it. After that, these are the important reactions that you need to remember. The Sand-Mears reaction, in which you are going to use Cu2Cl2 and HCl, the formation of aryl chloride and N2. Again, using the diazonium salt, Cu2Br2 HBr ArBr N2 CuCN KCN ArCN plus N2. I'm going to show you this physical properties, chemical properties. Okay, this is diazonium salt, N2 positive X negative means Ar, N2 positive X negative, Cu2Cl2 HCl, you will get Cl, Cu2Br2 HBr Br, CuCN CuCN. Remember, CuCN HCN, you will get Cn. This is Sand-Mears reaction. This is Sand-Mears reaction. In the Sand-Mears reaction, you need to choose Cu2Cl2 kind of structure. In the presence of no HCN, here you need to take KCN. Gattermann-Koch reaction, you need to take the copper powder. Copper powder means Cu and HCl. ArCl, how you can show? I will show you this. This is my diazonium salt, N2 positive, Cl negative, N2 positive, X negative, Cu, HCl. Then need to put Cl over here, Cu, HBr, need to put Br over here. Okay, this is Gattermann reaction. This is Gattermann reaction. Okay, N2 is the driving force of this reaction is N2 positive CuX. Okay, removal of this one. Then after the reaction of Ar N2 positive Cl negative on reaction with Ki, you will get aryl halide Ari and KCl plus N2. Ar N2Cl in presence of HbF4 Ar and 2 BF4 on heating ARF aryl fluorides BF3 and N2 is going to get removed. After that H3PO2 Ar and 2 positive Cl negative H3PO2 on hydrolysis you will get benzene. This is very important reaction and I am going to show you by writing this. Ar and 2 positive Cl negative and 2 positive Cl negative H3PO2 the case you will get the simple benzene ring, no other one. The removal of N2 in these reaction is the important one. After that this is Bal-Schiemann reaction. You need to remember the name of this reaction, the Bal-Schiemann reaction. Bal-Schiemann reaction. Here this one is Gattermann reaction. This one is Gattermann reaction in which we are using copper powder and HCl. Here this is Sandmeyer's reaction where we are using copper chloride and HCl. Next one is Ar and 2 positive Cl negative. In case of higher H2O you will get alcohol and N2 and HCl. Another reaction is coupling reaction, that is also very much important. When the coupling reaction is with the phenol, phenol and the phenol is like this, N2 positive Cl negative, N2 positive Cl negative, and this one is phenol OH H. This you are going to remove, you will get N2 N double bond N. This is the coupling reaction. This one is the coupling reaction. So this one is methyl orange dye, and another reaction is the removal of HCl. Over here you will get the yellow color dye of ammonia, benzene ring, nitrogen double bond, a benzene ring, and then the NH2 and the Cl and H2O. We have covered all the mind map over here. Just I am going to quick revise it. First one is the preparation of amines. Preparation of amines we have done with the help of the reduction of nitro compounds, analysis of alkyl halide, reduction of nitriles, reduction of amides, Gabriel's halamide synthesis, and after that the Hoffman bromamide degradation reaction. After that the physical properties I have explained to you. The physical property depends upon the hydrogen bonding that is in between the primary, then the secondary, and then the tertiary. Primary is more hydrogen bonded than the secondary one, and the tertiary one there is no hydrogen bonding at all. After that, the importance of diazonium salt is the formation of the substituted aromatic amines, because some aromatic amine is not get substituted easily. That's why the diazonium salt is better, is a better option. After that, I told you regarding the classification of amines. Amines is 1 degree, 2 degree, and 3 degree. So the classification of the amines is done. And after that, the nomenclature I have explained it to you, that the N-ethylamine, that is the IUPAC naming we have done. After that, the formation of alkyl cyanides and alkyl isocyanates. Alkyl isocyanates is formed by the AgCN. Here we have a covalent bond in AgCN. That's why the alkyl isocyanates is formed. And here the KCN, because of the ionic bond is there. So the CN carbon of the CN is more available to attack on this R. That's why RCN and Ki. The properties I have explained. One reaction, Schotten-Bowman reaction is there. Schotten-Bowman reaction. This is benzoylation reaction. Benzoylation reaction. Okay. So we have this one, NH2. We will take COCl. Okay. So this is going to attack on this in the presence of NaOH. Again, the same mechanism I am following in all the reaction. NHCO negative Cl C6H5. Okay. After that, oxygen negative. You will get NH. Here you will get a positive charge on this one. Positive. O negative, Cl negative is going to get removed. Cl negative take up this hydrogen. Again, nitrogen, hydrogen, CO, C6, H5, and HCl is going to get removed. This is benzoylation reactions, Schotten-Bowman type reaction. You just need to remember which one will act as a nucleophile and which one will act as an electrophile. Nucleophile, which is electron rich, and electrophile, which is electron deficient. That's why you just need to remember this one. Now, again, the physical properties I have explained to you regarding the diazonium salt, then the chemical properties, the Amines and the cation reaction, coupling reaction is very much important. Electrophilic substitution, in the electrophilic substitution, this reaction is very much important. Regarding NH2, HNO3, H2SO4, this reaction is very much important, that meta product is forming here in a good amount. Here I told you regarding the Hinsberg reagent, this is also very much important. Thank you so much for watching.